All right, this is the answer key video for topic 2.1 practice problems, types of chemical bonds. All right, there are lots of information in here, so lots of really good information. Please make sure that you are reading through the actual notes. But to hit the highlights here, the different types of bonds are really classified by their difference in electron negativity, okay? And this can be explained by using our best friend here, Coulomb's law. All right, so again, electron negativity increases going up and to the right, okay, or up and to the right, okay? And how we can classify different types of bonds here, okay, is in this electron negativity difference. Again, it's not the absolute electron negativity, it is the difference between the molecules that we are looking at, or sorry, the atoms that we are looking at inside of a molecule, okay? So again, if we're looking at A and B, if it is less than 0.5 difference, it's going to be a non-polar covalent, because they're, again, relatively sharing those electrons equally. Polar, on the other hand, electrons are being pulled towards one of the atoms harder than the other one. So again, here the electrons have shifted more towards B, okay? And that creates this difference in electron negativity, okay? And again, we'll talk about it in later units, but this bond dipole moment, we start to have a little bit of a dipole, okay? Then finally, ionic, that would be anything greater than about 1.7. Okay, because the electrons are totally transferred to the other atom, all right, and we now make a fully positive and a fully negative charge, okay? So again, lots of different ways of looking at this and seeing this. Again, take the time that you need here, okay? Also included in here are some really good properties of the different types of chemical bonds, okay? No, you don't have to memorize these, but you do have to be familiar with them, okay? They will show up in some way, shape, or form. So again, please familiarize yourself with the difference between ionics, metallics, and covalent molecules, okay? The last thing here that we didn't really talk about in class is this non-metallic or non-metal and metal characteristic, okay? So basically, we know that non-metals are on the right-hand side of our periodic table, and most metals are on the left-hand side, okay? So if we are going up and to the right, that is increasing our non-metallic character. So again, up here would be the most non-metal, okay? Opposite, going down and to the left, okay, that would be the most metallic character. Okay, so again, the atoms down here are going to exhibit the most metallic-like behaviors. All right. Again, you've got the I-dos here. Okay, place the following in order of increasing polarity. Okay, so again, that's talking about your difference in electron negativity. All right, the we do. Hopefully you watched the video here and we're able to classify. Now, for our first you do here, let me zoom in a little bit. Okay, so select 3 sets of 2 elements that would form a polar covalent bond and place them in order from least polar to most polar. So again, if we're talking about polar covalent, that means we need to have an electron negativity difference between 0.5 and 1.7. Okay, so again, you can pick any of these combinations that would give you an electron negativity difference of about those. So I picked CLF, CF, and HF, okay? And again, in order of least polar to most polar. So least polar is going to have the smallest difference in electron negativity, okay? So Cl and F, okay? Cl and F. That's going to give me an electron negativity difference of about 1. C and F, okay? C and F, that gets a little bit more, about 1.5, okay? And H and F is even greater than that, okay? On the opposite side here, select 2 elements that would form a non-polar covalent. So that is things less than 0.5. So again, looking at C and F, that's about 0.4. Looking at C and SF, that is 0, okay? And S, I, and H, okay? So again, these ones here just ask for non-polar covalent, not in any specific order, okay? With number 2 here, without referencing electron negativity values, place the following in order from least polar to most polar. So what we have to do here is, again, we are thinking about electron negativity, but we aren't given those values. So we have to go and use the general trends that we'd find on the periodic table. Again, lowest electron negativity being here, highest being here. So what we're really being asked is to look at the separation between them and the trends that we know. Okay, so for example, in the first one, SF, PF, and SIF. Okay, well, F is here. Okay, so we're looking at S, P, and SI. Okay, so right here would be the smallest separation. Okay, so that's going to have the smallest difference in electron negativity. Okay, then as we step over and over, we are now increasing our separation, so we are now having a larger difference in electron negativity. All right, same thing with the last three, FF, FCl, and FBr. Again, F's here, Cl, Br. Again, it's not about the absolute values, it's about the separation and the difference between them. So again, there's obviously no difference between an F and an F. Then as we step down, there's a difference between our F and our Cl. And then here, the largest difference is going to be between F and Br. Okay. Now, we're going to use a similar logic here for number 3. Without referencing our electron negativity values, we are looking for the pairs of elements, and we are looking to see this delta negative and a delta positive. So again, we are trying to indicate in this bond here, where are the electrons going? Okay, they're going to go towards the higher electron negativity element, or the element with the highest electron negativity. Okay, so that means that those electrons are going to get pulled closer. So again, for example here, F is going to have the highest electron negativity. So these electrons that normally would be right in the middle are now actually going to be pulled closer over here, which means they feel, this fluorine feels the effect of those electrons a little bit more and creates this partial negative charge. Okay, and what that means then is by contrast, hydrogen has to feel a partial positive. Okay. Same thing with the next one here. We have S and O. So O is the more electron negative value. So that's going to have the negative charge. Okay, where sulfur has a little bit less electron negativity. So it's going to feel that partial positive. All right, and finally, P and Cl, same thing. Cl is going to have the higher electron negativity value, so it's going to feel those electrons a little bit more, and that's what has the partial negative. All right, number 4, inspect the compound lithium hydroxide, LiOH. Is the bond attraction between Li and O the same as O and H? Describe both those in terms of bonds and attractions using the correct term. Okay, so the answer is no. Okay. Because if we were to look at this molecule here, it is Li, which is bonded to an oxygen, which is bonded to a hydrogen. So again, it's LiOH. OH here is together. Okay? So this here is a polar covalent, right? Because there's going to be a difference in electron negativity that's pretty substantial between the oxygen and the hydrogen. Okay? However, now that we have a non-metal, right, or this non-metal compound, OH, okay, and we have a metal, comparing the electron negativity differences between these guys is going to be an ionic bond. Okay, this is totally going to give up its electrons, or I'm sorry, lithium is totally going to give up its electrons and give that to the OH molecule. Okay. Number 5, circle the compound that is most ionic. Again, that means we are looking for the largest separation in our electron negativity values. And how we know that is the larger the distance on the periodic table. So sodium is going to be farther away from fluorine than our silver. So NaF is going to be the most ionic. Okay. Same thing here. Ba is farther away from Cl than it is from S. So this is going to be the most ionic. And lastly there, right, the SR is farther away than the Zn on the periodic table. So again, this one's just all about separation. And finally, based on locations of the periodic table, rank the following in terms of metallic character. Again, metallic character increases going down and to the right. So we're going to start with the one that's in the most upper right-hand corner. That would be neon. Okay, and we're looking to go down and to the left, right? That metallic character. So we'll go all the way from neon through barium. All right, and again, that one's just placing in order as you see here. Okay. Again, if you have any questions, feel free to reach out. Thanks, guys.